Assalamu alaikum students. How are you all? In this video lecture, our topic of discussion is quantum numbers. What are the quantum numbers? Quantum numbers are the numerical values. These are the numerical values which gives us information about electron or behavior of electron. Quantum numbers are the numerical values which tells us about electron that is revolving around the nucleus in an atom. We can find spin of electron, magnetic behavior, orbit and orbital. These four things we can calculate from the quantum numbers, and these three things, magnetic behavior, orbit and orbitals, can be calculated from Schrödinger wave equation. Schrödinger wave equation. And we can find the spin of electron by its self-rotation. If electron is revolving or rotating around its axis on clockwise or anti-clockwise, we can term it as plus 1 by 2 or minus 1 by 2. We can find all these information by the use of quantum numbers. There are four types of quantum numbers. First is principal quantum number. Principal quantum number. First of all, principal quantum number was used by Bohr in Bohr atomic model, and we show principal quantum number by small n or denoted by small n, and its value may be 1 to onward, 1, 2, 3, 4 and so on, depending upon the number of shells in an atom. It tells us or it gives information about the valence shell or electronic energy level, about distance of electron from nucleus or energy level, it also tells us about size of the atom, and if n is equal to 1, we can say that it's K shell. If n is equal to 1, it will be K shell, and it has capacity to carry 2 electrons. It can carry 2 electrons. If n is equal to 2, then there will be L shell, and it has capacity to carry 8 electrons. If n is equal to 3, it's M shell, and it has capacity to carry 18 electrons. Maximum capacity of number of electron is 18, and if n is equal to 4, then the shell will be n, and it can carry maximum 32 electrons. 32 electrons. Actually, these are the shells that were firstly explained in Bohr atomic model, but these principal quantum numbers are not sufficient to explain the behavior of electron. So Schrödinger solved this problem and introduced other quantum numbers too. Other quantum numbers, second quantum number is the Azimuthal quantum number. Azimuthal quantum number. Principal quantum number tells us about shell. It gives information about shell, and Azimuthal quantum numbers actually tells us about orbital or subshell. Orbital or subshell. It has value less 1, less 1 than principal quantum number, then n. So we can write its formula. L is equal to n minus 1. L is equal to n minus 1. Here L is azimuthal quantum number, so we can write another point. It is denoted by small l. It is denoted by small l. L may have the value 0, 1, 2 and 3. If L is equal to 0, then it's S subshell. S subshell. And if L is equal to 1, then it's P subshell. If L is equal to 2, it's D subshell, and if L is equal to 3, it's F subshell. We can calculate its value by using this formula. We know that first shell is N1 and has only one orbital, that's S. So we can write the value of N1. Then we can calculate N minus 1 is equal to 1 minus 1 and it's equal to 0. P subshell starts from second orbital. P subshell starts from second orbital. So we can write its value N is equal to 2. N minus 1 is equal to 2 minus 1 is equal to 1. And D starts from third orbit. D starts from third orbit. So we can write the value of N in case of D, 3 minus 1 is equal to 2. And F starts from fourth orbit. So here the value of N will be 4. N minus 1 is equal to 4 minus 1 is equal to 3. Subshells has a capacity to carry electrons. So in this, S has ability to carry only 2 electrons. P has ability to carry 6 electrons. D can carry maximum number of electrons or 10, which can be carried by D orbital, and F can have 14 electrons. 14 electrons. Azimuthal quantum numbers actually gives information about orbital or subshells, and we know that first shell, when n is equal to 1, it will have only one subshell, that's S, and if the value of n is equal to 2, then it will have S and P. Now moving to next. third quantum number is magnetic quantum number. If we have an excited atom, for example, we excite hydrogen atom in discharge tube or by heating its container, then we say that its electron jumps to higher energy level. It may be P or D or F. D orbital or P orbital may have different orientations along 3 dimensions. So, in magnetic quantum number, if we put excited atom in magnetic field, then we can see that there will be maximum spectral lines or different spectral lines for each orbital. This quantum number can give us information about magnetic behavior of the atom. Magnetic behavior of the atom, so we can write it as, tells us about magnetic behavior of an atom, and it can be shown or denoted by small m, and m may have different values depend upon the azimuthal quantum number. If S is placed in magnetic field, it will have just one orientation, and that is shown by 0. Its value is 0. We can say that magnetic value of S is 0. If P is placed in magnetic field, it shows 3 values plus, minus 1 and 0. We can say that P will orientate itself in 3 dimensions as Px, Py and Pz. Px, Py and Pz. Px may have minus 1, Py may have 0, and its value will be plus 1. Pz will have plus 1. If D orbital is placed in magnetic field, it will show 0, plus minus 1, plus minus 2. It will show 5 values, and it will have 5 degenerate orbitals, and those orbitals are dxy, dyz, dxz, x square y square, and the last one dz square. So we can write, we can assign the values to them. It will have the value plus or minus 2. It will have plus 1, 0, minus 1 and minus 2. D will have 5 values, and if we place F orbital in magnetic field, it will show 7 values, 0, plus minus 1, plus minus 2 and plus minus 3. We can find the magnetic behavior of electron or atom from magnetic quantum number. Now the last quantum number is spin quantum number. What is spin quantum number? Fourth one is spin quantum number. electron has two types of motion. First is around the nucleus, and second is self-rotation. Self-rotation. If electron is present in any orbital, it rotates around its axis, and that's known as self-rotation or spin. If this spin is clockwise, then its value will be minus 1 by 2, and if its spin is anti-clockwise, then its spin will be plus 1 by 2. If an orbital has two electrons, then the spin of that orbital will be 0. For example, we have one S2. In this case, one electron will be clockwise and another will be anti-clockwise. The sum of these two values, plus 1 by 2 and minus 1 by 2, will be 0. In that case, spin of electron will be 0. If we have orbital having just one electron, then we can say that this electron may be clockwise or it may be anti-clockwise. There are 50% chances of clockwise and 50% chances of anti-clockwise. If you have any question regarding quantum numbers, you people may ask in comment section, and now I am going to repeat all these quantum numbers in one table. Here is magnetic quantum, first of all, principal quantum number n. Second is azimuthal quantum number L. And third is magnetic quantum number M. And fourth is spin quantum number S. And here is the nucleus of one atom having first orbit, second orbit, third orbit, and fourth orbit. Now I will relate these these quantum numbers with this atom. Here n is equal to 1, and this will have just one subshell, that's S. And here will be n is equal to 2, and it will have s and p orbital or subshell. Here is n is equal to 3, and it contains s, p, and d orbital, and here is n is equal to 4, and it has s, p, d, and f orbitals. As this S belongs to first shell, so principal quantum numbers are shown before that orbital as the one S. In case of this, we can write it as 2s, 2p. We can write here 3s, 3p, and 3d. We can write in case of 4s, 4p, 4d, and 4f. Now, in case of quantum numbers, I am going to pick all this information in terms of quantum numbers. Here n is equal to 1. n is equal to 1. If n is equal to 1, then it will be K shell. It's K shell. And L will have just one S and its value is 0. In case of magnetic quantum number, again its value is 0, and spin quantum number may have plus or minus 1 by 2, depending upon the spin of electron. If n is equal to 2, then it will be L shell. It will be L shell, and it will have S and P. S and P. Here I should also write about number of electrons. It can carry 2 electrons, and its formula is n minus 1. We can calculate number of electrons in n by the use of 2n square. 2n square. Next, the value of L in case of S is 0, and in case of P, 1. S can have 2 electrons, P can have 6 electrons, so L shell can have 8 electrons. 8 electrons, and the value of M in case of P is equal to 0 plus minus 1. And spin quantum number may have different values depending upon the rotation of electron. In the case of third quantum number, that's third shell, if n is equal to 3, then it will be M shell, and it will have S, P, D. In case of S, again value of S for L is equal to 0, for P is equal to 1, for D is equal to 2. And S can have 2 electrons, P can have 6 electrons, D can have 10 electrons. So third shell or M shell may have 18 electron, or its maximum capacity of electron is 18. The value of magnetic quantum number for D is equal to 0 plus minus 1 plus minus 2. And spin quantum number will show as usual value depending upon the rotation of electron or spin of electron. If n is equal to 3, if n is equal to 4, then it will be n shell, and it will have azimuthal quantum number S, P, D and F. S, P, D and F. The value of L for S is 0, for P is equal to 1, for D it is 2, and for F it's 3. And it have number of electrons 2, P can have 6 electrons, D can have 10 electrons, and F can have 14 electrons. So N can have almost 32 electrons. The maximum capacity of F is N shell is 32. F can have 14 electrons, and the magnetic value for F, M is equal to, for F, 0 plus minus 1 plus minus 2 plus minus 3. F will have 7 values, and spin quantum number may be different depending upon the number of electrons and their spin. If you have any question, regarding quantum numbers, you people may ask in comment section. Thank you, and don't forget to subscribe my YouTube channel and share my videos to others. Thank you and Allah Hafiz.